Hey 12s, here's the second part of this video. Right, we're here at last. More integration stuff. We're looking at the area between two curves now. Area between two curves. A couple of things to keep in mind. That we want to do the top one minus the bottom one. Now sometimes should they intersect between the bounds that we're interested in, right, we're going to have to dissect that area as well, because the top curve, the curve that's on top, is going to change when they intersect. In the first example we've got here, that doesn't happen. That's fine. They will only sort of intersect twice. We're going to look at the area in between. So we've got a parabola here and a straight line here. Right, and it asks us to find the 2 points where they meet. Okay, and we can work that out by saying that x squared minus 4x plus 2 equals x minus 2. Right, so x squared minus 5x plus 4 equals 0. So x minus 1, x minus 4 equals 0. Therefore x equals 1 or x equals 4. We can find the 2 points where they meet. Right, I suppose it does say find the 2 points. If that's an exam question, I need the y values as well. It's not generally important for the integration, but it does say find the 2 points. So if we substitute back into y equals x minus 2, so the 2 points are, well, 1 minus 2, 1 minus 1, and at 4 minus 2, 4 to 2. Right, there's my 2 points. Draw a sketch. Yeah, here's a bit of a tip. Draw the parabola first. There's my parabola. Yeah, it's going to look something like that. X and Y. And righto. So this is going to be y equals x minus 2. This one is going to be parabola. I don't have a lot of room there, and I'm interested in the region between those two curves. Right. That's this region here. Now that point there is 1, and that point there is 4. You can see that the parabola is always below the straight line, so I am going to integrate. My integrand is going to be x minus 2 minus x squared minus 4x plus 2. Right? So my area equals the integral from 1 to 4 of x minus 2, that's the top function here, minus x squared minus 4x plus 2, or with respect to x, right, which is going to equal, in fact it's going to equal the integral of this. Right, so I get equals a third of x cubed plus, oh sorry, it's a negative there, a negative of a third x cubed plus 5x squared, or 5 over 2 x squared minus 4x from 1 to 4. Substitute those figures in there, and we are going to end up with, when all's said and done, 9 over 2, or 4.5. Be really careful with the arithmetic here. It's a whole lot of adding and subtracting. That's all it is. It's easy to make mistakes. Okay, so as I go, that's all right. So that's the first one, where I have the area between two curves. Don't worry that some of it's below the x-axis. That all sort of gets cancelled out when I do one minus the other. If it's just between two curves, you don't have to worry about the positive and negative bits. What you do have to worry about is what's happening here in this second example here, is where there's the same curve isn't always on top. Okay, now we've got a diagram this time. I've got, again, two quadratics, or two parabolas. One's positive, one's negative. And we're interested in the area of the shaded region here, right? Let's scroll down and have a look at this diagram. Okay, so you can see that between this sort of shaded region from 0 to 2, right, the positive function is on top. The positive parabola is on top. From 2 to 4, it's the negative one that is above. So I'm going to need to work out my area is going to be the integral from 0 to 2 of, right, in fact, yeah, scrolling back and forth, I've written it down here, of x squared minus 8x plus 12. It's that thing. Now I need to subtract the lower one, minus negative x squared plus 4x minus 4. Dx, so that's this area here. Right, that's the first area. Is done like that. In fact, let's go A1. Otherwise it's going to get a bit messy. I'm just going to call that A2. Right, so A1 equals this. Now, that gives me, right, I sort of tidy all of that up there, and I get the integral from 0 to 2 of 2x squared minus 12x plus 16 dx, and right, I integrate that and I get 2/3 of x cubed minus 6x squared plus 16x from 0 to 2. Right, fortunately the zeros don't cause me too much problems there, and I end up with, what happens, what do I end up with for that first one? I think I end up with 40/3. Oh, hang on a tick. Yeah, just checking my figures there. Equals 40/3, or 13 1/3. 13 1/3 square units for the first one. Now, second area, area 2 this time, equals the integral. Now it's going to be from 2 to 4 of the opposite. I'm going to take that, I'm going to take them away in the opposite order. Right, so that's going to be the, let's have a look. We need negative x squared. Negative x squared plus 4x minus 4. We've got this, and we're going to subtract the x squared minus 8x plus 12. Right, take that away, differentiate with respect to x. Right, and this time I get the integral from 2 to 4. In fact, really, this is g of x minus f of x, as opposed to f of x minus g of x. We just get the negative of this. I get negative 2/3. Oops. Oh, sorry. We can jump straight. We can jump the gun a little bit here. You can work this out if you need to, but we get the integral. Oh, sorry. I need to evaluate. I need to substitute in to negative 2/3 x cubed plus 6x squared minus 16x from 2 to 4. And if I evaluate that, I get 2 2/3. Therefore, my total area equals 13 1/3 plus 2 2/3 equals 16 square units. Righto. Just be careful there. You either need to be given the sketch or you'll need to draw a sketch to check how many times they intersect, right? Which one's on top. But the top one minus the bottom one. Okay, so the top function minus the bottom function, and then you integrate the difference of those two functions, and that's going to give you the area between them. Thanks, guys. Good work.